Hi students, today let us learn about electron dot structure for oxygen molecule. Oxygen is having atomic number 8, and when we look at the electronic configuration it will be 2 comma 6. Oxygen is having an atomic number 8, and if we distribute the electrons in K and L and M shell. So according to 2n square rule, maximum number of electrons in K shell is 2 and the remaining 8 minus 2 is 6. So here when we look at the outermost orbit, it is L shell which is and having 6 electrons. But we know that every atom in the periodic table wants to attain stability by attaining octet configuration. That is, all atoms want to possess 8 electrons in their outermost orbit. So that is the reason why needs 2 electrons. And that is possible when oxygen will share its electrons. So here observe. So when you look at this, so as I already written 6 electrons. So 1, 2, 3, 4, 5, 6. And these 2 electron is being shared by adjacent oxygen. So that's the reason how covalent bonds are formed between two oxygen atoms. This is the oxygen, two oxygen atoms shared by oxygen number 1, and these are the two oxygens shared by oxygen number 2, if I just name them like that. So hence overall there will be, if I count the total number of electrons around each oxygen, there will be 8. So what you can see here, observe in each of the circle, if we count the number of electrons, so if I go on counting 1, 2 plus 2, 4, 4 plus 4, 8 electrons around first oxygen. Similarly, 2 plus 2, 4, 4 plus 4, 8 electrons around oxygen 2. So hence, oxygen molecule is a diatomic molecule, and there are always, and it is always having double bond between two oxygen atoms. So the first bond is always sigma and the second one is pi bond. So this is how we write the electron dot structure of oxygen. Now next molecule we will understand is nitrogen. So we all know nitrogen symbol is capital N and the atomic number is 7. So if I write the electronic configuration or arrangement of electrons in K and L shell, K shell will have 2 electrons and 7 minus 2, 5. So L shell will have 5 electrons. So now if you look at the outermost orbit L shell, it is having 5 electrons and it is deficient of 3 electrons to attain octet configuration, because 8 minus 5 is 3. So hence nitrogen, what it will do is it will share 3 electrons with adjacent nitrogen atom to form covalent bond. So here what you can observe here is 5 electrons. So each nitrogen is having 5 valence electrons. See, whenever we are writing electron dot structure, remember students, we are only mentioning the valence electron, not the innermost electron or not even the penultimate electron. We are always referring to the outermost electron. Okay, so here nitrogen is having 2 plus 2, 5 electrons. Similarly, the other nitrogen is going to have 2 plus 3, 5. Okay, and as I already told you, each nitrogen has to attain octet. So it is possible only when each nitrogen atom will share. So the first 3 dotted lines are nitrogen atom of first nitrogen, and the second 3 dotted lines are 3 electrons of the adjacent nitrogen. So hence here you can observe that there is, it's like a sharing. So this structure is mainly representing sharing of electrons. So that's how when you count the total number of electrons around each nitrogen, it should be having 8. So here 2 plus 6, 8. Similarly, the adjacent nitrogen 2 plus 6, 8. So 8 electrons are total number of electrons around each atom is 8, and hence it gains stability. Okay, so that's how molecules gain stability. Only when they attain octet configuration, molecules or atoms attain stability. So that is the reason why whenever we represent nitrogen, we are always writing N, 3 bonds and N. So here what you can observe here, 3 dotted line is nothing but 3 bonds. Okay, so that's why nitrogen, it is a diatomic molecule N2, but if you look at the number of bonds between nitrogen atoms, it is 3. So one is sigma and two are pi bonds. Thank you.